Hello, my name is John Coonrod with Rogers Corporation. Today I'm at IMS 2017 and I want to talk to you a little bit today about datasheets and how to compare datasheets appropriately. Now besides that, I'm also going to talk a little bit about millimeter wave material characterization because that's typically not on datasheets. So to begin with, datasheets, if you're comparing materials like material A to material B and it's Rogers materials, then that's usually a pretty easy comparison because on our data sheets we do use the same test methods, same conditions, things like that. So that's usually not an issue. So sometimes what the issue is if you're comparing our materials to another manufacturer materials, that's where sometimes it gets a little iffy because sometimes they're not using the same test methods we're using, or they may be using the same test methods and different conditions, and then it's not really a fair apples-to-apples comparison. So just to give you an example, I guess really the best way to start off is to think about most of the printed circuit board materials that are used are anisotropic, meaning that the dielectric constant and other properties are not the same on all three axes, the X, Y, and Z axis, Z being the thickness. And because of that, you can actually test the same sheet of material in one test method, take that same sheet of material, test it in another, get two different answers, and both those answers are correct. Now that really bugs the RF guys, obviously, but that's a fact, and that's because some test methods are testing the Z-axis only, and other test methods are testing the XY plane only. And when that happens, you can get two different answers, and both answers are correct. So that's where a little bit of confusion comes in from. So when you're testing or taking a look at data sheets from Rogers materials to another material, it's always good to make sure you're using a good comparison that has the same test methods. And then besides that, also the conditions are important. So in the case of dissipation factor, we see this very often where the same test methods are used from one data sheet to another, but sometimes it's a different frequency that it's tested at. And dissipation factor does change with frequency, and basically lower frequency you will have a lower dissipation factor. And what that means is sometimes you can see on a data sheet someone's reporting a dissipation factor of 0.001, which is considered very good, but if that's only at 1 megahertz or 10 megahertz, that's really not that meaningful. Now if you get 0.001 dissipation factor at 10 gigahertz, like what's on our data sheet for our 3003 materials, let's say, that's pretty significant. That's a very low loss materials. So even though the test methods are the same, ensuring the conditions are the same and the frequency is the same, that's another important aspect of comparing data sheets. So that's another thing to keep in mind. Now there's some other aspects too besides electrical, and there's also things like thermal conductivity, there's peel strength, moisture absorption. Each one of those test methods have their own little quirks, you might say. One of them that we run into that pretty often is thermal conductivity. And what we do at Rogers is we test our materials for thermal conductivity, and we're testing the raw substrate. Some other manufacturers, sometimes we see them testing their materials for thermal conductivity with including the copper effect, and copper is very highly thermally conductive. So that's kind of adding a little fudge factor to it that we normally don't do. So when comparing thermal conductivity from one data sheet to another, it's good to make sure you are comparing the same test methods and also the same conditions. Now, a topic that is typically not on data sheets is millimeter wave characterization. And Rogers does have the ability to characterize our materials at millimeter wave, and we can characterize the materials from a very wide range, from about 10 megahertz all the way up to 110 gigahertz. And that information is typically not on data sheets, Rogers or anyone else's data sheets for that matter, because there really is no industry standard test method for millimeter wave testing. So we do this type of testing off to the side, and we invite our customers to contact the Rogers representative to get more information. But you can see behind me actually some aspects of some of this testing where we're actually testing our RT Duroid 6002 materials, showing the difference between bare copper and ENIG. And this is going from about 10 megahertz out to about 100 gigahertz in this case. So we're able to do that. And again, this is something that's not on data sheets normally, but we do have that information, and we invite our customers to talk to us and get more information. So that's all I have for now. Thank you very much.